We are conditioned to imagine apex predators like this, as unstoppable monsters roaming freely through the fog, ready to cross into our world anytime. But the biological reality is different. True apex predators are highly fragile biological machines, completely beholden to rigid environmental limitations. To understand exactly how much of a threat they actually pose, we are going to count down the top 5 largest terrestrial and marine carnivores on Earth. This graphic shows the framework dictating where animals survive. A habitat must provide a dedicated water source, extreme shelter, vast space, and massive caloric intake. For apex predators, satisfying food and space needs consumes the vast majority of their evolutionary budget. This creates a biological rule we call biome lock. When an animal evolves extreme physical specialization to support its massive size, it guarantees dominance in one specific environment, while leaving it poorly equipped for any other. This biological limitation defines the physical boundaries where these animals can exist. Biome lock restricts their geographic range to specific, often remote environments. We can see this in action by mapping out specific biomes and dietary needs for the top 5 predators. After we map their habitats, we run a 90-second data breakdown to look at human interaction statistics. Understanding a predator's true capacity for danger requires analyzing these biological constraints, rather than just looking at the size of their physical weapons. Terrestrial environments like forests and deserts are highly fragmented. The dense trees, rocky ground, and limited rainfall impose severe physical limits on how massive a land animal can grow. This brings us to ranks 5 and 4. These terrestrial predators rely heavily on dense woodland environments to provide the complex shelter necessary for ambush hunting. Because they require those specific conditions to hide and hunt effectively, they find themselves restricted to highly specific, often shrinking, woodland zones. There is a sharp biological trade-off here. Evolving to rely on camouflage across vast tracts of hunting space limits their overall population density. Rank 3 shifts our focus away from the trees and directly into the extreme dry and hot conditions of the desert biome. Surviving on this sandy, rocky ground with minimal rainfall requires highly specialized adaptations focused on water conservation. By adapting to navigate these complex, dry terrains, our terrestrial mid-tier predators forfeit the biological capacity to reach massive oceanic sizes. Rank number 2 is the polar bear. This is a predator defined by the freezing, ice-covered conditions of the Arctic biome. The biological input required to survive here is enormous. They have to develop extremely thick fur and specialized blubber just to withstand the constant sub-zero temperatures. That heavy insulation comes with a major trade-off. It makes them physically incapable of surviving or hunting in warmer environments, like deserts or open plains. The second trade-off is their total reliance on sea ice to reach their specific food sources. Without the ice, they cannot hunt, which leaves them hyper-vulnerable to changing global temperatures. That brings us to rank 1, the giant whales, animals defined by the deep, wet expanse of the ocean biome. The biological input for giant ocean carnivores is colossal body mass. That bulk stores immense energy and generates incredible swimming power. To support that kind of size, they require a giant body of salt water. The water naturally supports their immense physical weight and facilitates their movement. The ultimate trade-off for achieving rank 1 is physical. They are entirely bound to the water, with zero capability to traverse land. Because they cannot leave the deep water, terrestrial encounters are naturally eliminated. Becoming the largest predator on Earth results in natural geographical isolation from human development. This dynamic bar chart brings us to the threat matrix data dive. We are going to use the next 90 seconds to run a direct statistical comparison of annual human interactions. First, we need a statistical baseline. The towering columns copulating right now represent the massive volume of daily interactions humans have with common domestic animals and standard herbivores like deer. Now, watch the world map overlay behind the chart. We are mapping the isolated geographic lock of our top 5 predators. Notice the zero intersection between human population density and the remote Arctic, deep ocean, and dense forests. When we plot the interaction data for ranks 5, 4, and 3, you get 3 tiny bars at the very bottom of the axis. The barriers of dense forests and harsh deserts keep their numbers exponentially lower than domestic animals. Finally, look at the polar bear and giant whales. Extreme environmental barriers turn their data points into nearly invisible slivers on the baseline. Casual encounters are nearly impossible. When interactions with these animals do happen, they are almost exclusively the result of humans making the conscious choice to cross into those extreme environments. The statistical risk of human interaction is inversely proportional to a predator's extreme biological capability. Moving from biological theory to logistical reality, we need to look at what it takes to actually observe these massive carnivores. This quadrant chart maps the accessibility of their habitat against the frequency of human interaction. As we plot all 5 predators, notice how they group in the extreme upper right quadrant. Their biological size forces them into the most inaccessible, isolated regions on the planet. The logistical cost of reaching that quadrant is heavy. You need specialized survival gear and extensive planning just to safely enter Arctic snow or ocean depths on the animal's terms. If you are part of a high-investment audience, like a wildlife photographer or a dedicated eco-tourist equipped for extreme operational friction, pursuing these sightings is rewarding. But for a casual viewer, it is advised to temper your expectations. You cannot expect safari-level convenience when searching for an animal that relies on polar ice or deep ocean conditions to survive. The exact biological adaptations that allow these carnivores to achieve massive size are exactly what ensure they live safely out of human reach.